Very frustrating. Alright, so hey, train your plants every day. Jordan Scoville coming at you. Now, again, if you know something about me, I'm just making this video up for YouTube concept. Well, a lot of things I do is a lot of psychology and a lot of physics, quantum physics, mathematics. So whether it be algebra, geometry, trigonometry, all of them kind of share a fundamental base. In quantum, you got to kind of go quantum, but it's one of those things that I conflict with a lot of this thing. I don't necessarily agree with a lot of it. I'm one of the critics. If you read String Theory for Dummies, because we don't necessarily need those models. But that's like a different question. Again, they still have a lot of questions within that they'll ask you to do. Just like the STEM problems and the Millennium problems, a lot of them have very simple answers that really can't be solved. You can't really apply a algebraic answer to some of this material. Alright, enough. And you can't really find geometry for it. I'm going to give you some of those examples because it comes up in a lot of material. So what I've been working on is something like this. Alright, and this seems very simple, that what this is, but there's a lot of choice to the geometry, the quadrants, the geodesics of this straight line, and how this creates a much larger line or a string of bosons and fermions and strings and brands and quarks and lipids, and how it forms elements, and its number theory concepts, and again how you could look at this and then parallel them to physics equations, Ohm's law, laws of motion, Albert Heinrich's last theorem. I mean, all of them will apply, but it becomes a really chaotic mess about kind of what's happening here with the logic choice problems that you create. Now again, when you just think about this, well, this doesn't look like a very complicated thing at all. Well, again, it's not. But again, up to this point, it's almost falling down to zero, but we continue this. What is the size of the paper I'm dealing with? Is this one straight line of not continuing down here at a new platform because we're integrating A is a quadrant problem, and this 4x4 is also 4 positions that reference 4 different things at the boson level and what they could be, 4 elements that are based in that system, or 4 mathematical functions, Planck spectrum, that determine what that is. Again, it's really crazy in terms of how am I going to order universal field theories to determine what they are at this level. So we're going to continue this pattern, but it's going to remain to this law of motion. A in the first corner, we're going to start in that position, then it travels x over, y down, z across. That's what we did. X over, y down, b over, or z over. This is also going to continue when A transmits a different position, or if I add c. Which choice do I make? What I like to call this is it's a great little puzzle to work. It's a time killer, it's a brain builder, and being able to form elements. This is basically my Hadron Collider, because there's so many different patterns and choices and new elements that can be created that apply to the laws of motion and can defy the laws of motion in this geometry. You could say later, when you get into more complex variations of this thing, once you run a certain sequence, that BAC or BAC is the pattern that still applies to X and Y correctly based in this pattern sequence. What you're dealing with a lot of that stuff is that problem, is this logic selection of the form state you deal with, which type of form state, understanding the total end result. If you know those equations, they're all zeroed out, or they have causal speed. If you don't know the end result, if you don't know the stone dock and the numbers of boards you're doing, or the numbers of rotations, or the amps you're dealing with, then it's not really practical to work a lot of those other equations. They don't exactly work. Things start to break down at the quantum level. You don't know gravity. If you don't know that what the Hadron Collider is a process of ramping up bigger magnets and bigger electromagnetic fields to reduce this instability of what's happening in an equation like this. It's very unstable. We're just building this process in a small 4x4 grid. But yet we'll have way more than 4 selections just by using A in its position. We'll get 4. Just by using A, B, and the series of that Newtonian system, bosons and fermions systems, and things like that to apply, that it is very, very unstable. So when this thing shoots downrange, they don't hit perfectly center mass, and you have a lot of diversified inconsistency. You have a lot of choice. You have a lot of, and choice creates a lot of diversified inconsistency. We don't have law that says it's going to work exactly like this. In understanding the smoothness of general relativity and the quest to make quantum gravity this very smooth process where everything starts to break down at the fractal level. I'm looking at that board on the stone dock. I know I can cut this many pieces, and I can tell you acceleration. I can tell you the velocity between smaller frames of the process where I hit this button and I put a board on. That does concern at the very geometric level, me being this thing that isn't a very smooth object. It's a globular state. If you know the Nova-Stroker's air turbulence equation, if you're smoothness in existence, or if you're using a fluid dynamics problem of in a pipe, or hydraulics of the pressure problem that you're dealing with, that you have a lot of that same turbulence problem, but here it's based in space and time. I don't know the volume sizes. Only when I know those things would it determine the gravity to give me a specific end result. Otherwise, I just use those equations to generalize it. And I would have to then add those numbers. I'd have to go look at their weight, look at their number, look at how much gravitation they have, essentially. And that's the idea behind general relativity, is that what's relative, where resistance is stronger than force, but equal to force. Again, right there, that's A. Force. Then I have a force that created a resistance against that in those two states. Yeah, I'll be down in just a second. Those two states created a stability that without... I said I'll be down in just a second. That those two states, without the force, there is no resistance. Without the aspect of the initial force with a resistance, or just the act that there is a resistance against that force, creates a new force, a new state, a decay, the half-life that next to this other element makes it decay faster because it's nuclear half-life. We're talking about radiation. We're talking about how when I set this on a piece of paper, it's going to create a shadow underneath there. It's going to block sunlight. It's going to just sit here and be plastic next to a thing and have its electron pass through it, because at the atomic level it's a wave, not necessarily these particles. And that's going to make it potentially decay faster. It's going to create these aspects of resistances and other forces that are essentially dark matter that create this force in this universe, but just by acting with each other next to other elements. How they act with each other next to this idea is going to create a very mechanical force or gravity. Alright, again, and we find that by creating forms, whether they be in the practical level of checklists. When I apply a checklist to a company I never did before, the numbers change. You know, why was it all hodgepodge and out of order and didn't have any consistency, like the element or this hunk of something? What is the consistency? You know, by terms, A is a broken long sequence of reciprocating terms in algebraic thinking. It's an A group thing, it's psychology, it's how this, you know, this molecular instability and all different XYZ principles, and it's not really 3 dimensions, right? It's 1 dimension. It's a 0 binary system, but as they stack into a single dimension kind of way of thinking about a thing. I'm still looking at the stone dock and all of its 3D principles, but with a space-time problem in the 4th dimension, we're talking about something in 2D. This timeline, this sequence of, in this box, of its XYZs, of this board's, its description, and, you know, the quality assurance that may go with that, to extra states, to special relativity to tell me exactly what's going on there, higher in-depth models of it. That it determines its specific value, its specific atomic mass, its specific atomic weight. In the system, it's going to slow, by having weight like that, it can say that it's more dense and it'll fall faster in water, or it'll travel faster in air because it has more momentum by doing this. And again, it's positive, negative kind of stuff. Sometimes by knowing that number, it helps me increase it. But if I don't understand that number, it's going to negatively affect everything. By looking at that number, I'm looking at everything that negatively affects it to create a positive effect in this space-time, time-space problem, fifth-dimensional calculations and the Lorentzo's transformation and Planck spectrums of general relativity, and how we understand them to be fairly smooth. So I said one on Facebook the other day that I'm using a dildo race as my opener speech for psychology and quantum physics, an abruptly long sequence of reciprocating terms that have to stay within these lines in this quantum machinery that get to the end first. You know, who comes first in this, you know, quantum speech? Well, this could be the right answer. It's gonna reference not only in this form. You'll find when you go to try this, when you really know what you're doing, you could easily just write it out. Oh, well, that's obviously the right answer. But when you start to play around with the positions, A over here first, between B, before I added C to this, that there are a lot of variables. Or I could just start in this form and go to C, because I filled out all that position in the same form. A maintained the same first position. Do I go to the second position and continue that same thing? There's a lot of instability here. And there's going to be a master geometry to how many power series, how I position that on the piece of paper to maintain that geometry again. Because that's the philosopher's stone, or the machinery you're working with to actually process this equation. So with that notation, I said I was going to do one for myself. This is a practice run, because this is the physics speech. This is, even if you do patent this, you got to explain how it works. You got to reference the IKEA. All right, this board goes here, then this nut goes in it, and that's what each of these positions are kind of referencing. You know, A is the boson. That boson might break down into 4 positions in a Newtonian order, and after that point, it's bedlam, mayhem, chaos theory still remains. And we're going to have to use observations and trial and error within this entrope idea of checking and inventorying all those things, which is, again, very practical skills worth learning. Which here, again, being that this is a fun game, you might not be able to do it on the stone dock. But the same observations you're doing on the stone dock, or in a board factory, in a hotel, by determining, you know, this is why a week, a month, a year, I do certain things in that variable on your inventories checklist, or I had a bunch of customers this week that come into that, are the same calculations. This is supposed to build you a fundamental idea of that, because to make improvements where you think everything is pretty stable when it's not stable. This is stable. It's not stable. For, you know, how unstable it is, it still references something that's very physical, very stable. Bipolar is something that is only a term, that you don't shoot somebody in the head because they have bipolar disorders. You build something, you give them a pill, you reference their home life and their physics, you use social liberty for drug usages and things like that, and you got to get it back on track. And that's by creating a form of analyzation and determining the choices and a bunch of other things, the elements, the particles, the wave functions that play off in time sequences and distances that don't really exist. An inch isn't really an inch. It's only an inch because we determine what that is a social group, a group, and a abruptly long sequence of reciprocating terms. It's only useful when I'm using it in those scales. Time and distance are an illusion. You know, I could use a car to travel a mile, and that totally screws up the machinery, and we're not going to get past that. You know, at the elemental level, where it actually applies a little differently, alright, but I don't need uranium to make a power plant. I don't need uranium to save money in a power plant when I'm using those same calculations. Again, when you look at the fundamental design of what's happening here, A level, B level, the number theories that go with that, both are the same thing on this geodesics that equal at the same point at the same time. Quantum mechanics. Catch you on the next one.